So I want to continue this from the last video that I made, lesson number 7.4. Last time we did problem number 1 to 3, and now I'm beginning problem number 4. We got the fundamentals right, exactly how to go about. Let's see how do we do this one. So you have 4 sine square minus 4 sine theta. So you need to know quadratic, how to solve quadratic equation. What we do here is we'll plug this in place of sine square. If there is a sine square, so let's replace sine theta is, let's put it like a p here. So this whole thing reduces to a quadratic form, 4p square minus 4p plus 1 equal to 0. And then how do we factorize it? So you know so many different strategies. What I would do is use your old strategy where you multiply 4 times 1 is 4, and 4 we can split as 2 and 2, and 2 adds to 4. The only way you can do is, so in order to get a negative, in order to get this negative 4, minus 2 and minus 2 adds to negative 4. So we can write this as 4p square, and you can write minus 2p plus 1 equals 0. So we can factorize here. You can see this, so the 2p is the common, so undo distributive property. So that way you can write 2p. So what stays is 2p minus 1. Now in this case there is nothing common, so I'll just write negative 1 outside, and this will be 2p, change the sign to minus 1 equals 0. Now you have the 2 parentheses which are the same thing, so I put a color to this. So this is the one which looks alike. So you pull it out, 2p minus 1, and then you get the remaining. What stays is 2p minus 1 equals 0. And you can see it's the same thing. So zero product properties say either one of them has to be 0. So sometimes it could be different. So you say 2 by p minus 1 is 0, or so basically it's the same thing. I don't have to write twice, just write 1, add plus 1. So this will be 2p equals 1 divided by 2, and you get p equals half. But what is p stands for? Back to sine theta. So sine theta is half. Okay. So now, like what we did for problem number 3, let's do that now. So what did we do is, this is positive, so you know where is sine positive. So I'll just put 2 places. Sine is positive, and the definition sine is nothing but it's the y coordinate, and you know that sine is positive in the first, and so this is plus, and also this is minus plus. So definition of x and y, say xy, this is sine and this is sine. Sine is positive in the second quadrant. So one of the angles that you can think is, this is the first quadrant and this is the second quadrant. In the first quadrant, you can directly say, you can directly write sine of what angle is 0. So what sine of what angle is half, and you can see this part like this. So sine of pi 30 degrees is pi by 6. So here theta is, one of the angle is pi by 6. There you go. And the other angle you can think of is 2 ways you can do is, remember how many 30s, so how many 30s make a whole round. So if I have like this, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 30s, right? So you want to go back to here. So, or the right way to do is, so this is pi by 6, then this is 2 pi by 6, 3 pi by 6, and there is 4 pi by 6, and then there is 5 pi by 6. So we'll use 5 pi by 6. So this angle is 5 pi by 6. So one of the angle is pi by 6, and the other one is 5 pi by 6. Or if you get confused with this, to go in the second quadrant, this is pi, so it will be pi minus this angle is pi by 6. So you want to know how much is this angle, right? So to know this angle, you'll have to take away this from pi by 6. So pi by 6 and you get 5. So this multiply 6 here. So 6 minus 1 is 5 pi by 6. So that's how you figure out 5 pi by 6. You may be thinking, why did I not take this? This is 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6. So this one which is 4 pi by 6 reduces to, if you see 2 divides 4 and 6, so you get 2 pi by 3. So that is the multiple of pi by 3. We want pi by 6. Okay. So that's why this is 5 pi by 6. So now once you get this, then just write theta is pi by 6 plus, and because of the period of sine is also 2 pi, you just write 2 pi k. And here you write this one is 5 pi by 6. So this is one of the angle, and the other angle will be plus 2 pi k. And k is integer, k is integer. So bottom line, I think you guys can get confused is here. I think how do we figure out? Let me do it just one more time. So if this is the unit circle like this, you do know that pi by 6 is, this is pi by 6 which is 30 degrees. This is 30 degrees. So this part, so, and here sine is half, because sine of 30 degrees is half. This is sine of pi by 6 is half. And you see on the other side, this point, you can see here, this point is, if this is plus, this also is plus half. So all you are trying to know is how much is this angle. So to figure out this angle is, this you already know this. So to know that it's like pi, this is 360, all semicircle is pi. So this is pi by 6. So from pi by 6, it's like you're taking away pi by 6 and you get that answer. So it is like pi minus pi by 6, where you multiply 6 and 6. I'm repeating this again just to get that answer. So we get pi by 6, 5 pi by 6. So instead of doing this, you could also do directly, is the moment you are given pi by 6 here, this is pi by 6. So you go in the third quadrant, you just have to think of how many pi by 6 how many pi by 6 do you have to go here? And the only way is 1 pi by 6, 2 pi by 6, so it is another pi by 6, 3 pi by 6, another pi by 6. Then there is 5 pi by 6, 4 pi by 6. I messed up here. This is pi by 6, pi by 6, pi by 6, then another pi by 6. So this is pi by 6, this is 2 pi by 6, this is 3 pi by 6, this is 4 pi by 6, and this is 5 pi by 6. So we want this angle, see this part. So this is 5 pi by 6. We can't take this 4 pi by 6 because 4 pi by 6 reduces to 2 pi by 3. So that doesn't help. So we have to have a multiple of pi by 6. It has to be the same height. See this height and this height, the y coordinate is the same. This height. So if that is half, this also has to have. It cannot be this point. So you have to reach here. So the goal is to understand why you are taking 5 pi by 6. Okay, now let me go to the last two problems there. Is this problem, again we can replace cosine theta. So I'll write here, replace cosine theta is p. So this whole thing reduces to is p minus 12 equals 0, and there's already here 1, so we just have to split this 12, negative 12 as 4 times 3 is 12, and negative 4 and positive 3 is negative 1. So these are the good choices, and you can write this as p plus p minus, so you have 2 factors equal to 0. Let me write this 6th problem here. Instead of x, let me put theta. So this is p minus 4 and p plus 4, plus 3, sorry. Now, using zero product property, either you say, okay, the first parenthesis is 0 or the second parenthesis is 0. You add plus for both sides, and then you add subtract 3 both sides, and you get p. But then you can replace p back here. P is cosine. I'm going to replace here. Become cosine theta is 4, and here again p is cosine theta equals minus. Now remember the range of cosine. Can you have a, is there an answer for this? Suppose I write theta, cosine of what angle is 4. And we know that the range of sine and cosine, remember, is from -1 to +1. If you remember this, cosine is this way, see? So that means the range is always between -1 to +1. So you cannot have cosine values, cosine angles more than 1 or less than -1. This number is greater than 1, this number -3. So we say it does not exist. There is no solution, does not exist. Or you can say no solution. This problem now is, make sure we first, I want to make sure whether I copied it correctly. Four cos cube minus 4 cos x here. So we'll try to put, okay, this one, what I'm gonna do is, let's put cosine of theta. If I put a p here, so this will be 4p cube equals 4p, subtract 4p. Let's see why I'm doing this. And if you subtract, this becomes 4p cube minus 4p equals 0. Or you could also divide by 4. See, there is a 4 there, this is a 4. We don't need this 4, so this is like p cube. And you just have to do this. So it makes it easier like this. And then you can see there are 3 p's, so one of the p's could be taken out. So this will be p, and there will be p square remaining. And this is p times 1, so there's a 1 stays, so equals 0. And then you have okay, so what this means, we use the zero product property, and this p square minus 1, we can write it as p minus 1, p plus 1. So this is p into, because difference of square, 1 is same as writing 1 square. So it is like a square minus b square is a minus b, and a plus b. So using that, we can write it as p minus 1, and p plus 1 equals 0. Makes sense? So that means there are 3 of them. 3 of them means p is 0, or p minus 1 is 0, or p plus 1 is 0. So there are 3 of them. So let's replace this, adding plus 1 to it, plus 1, and subtracting minus 1. I'll make a room here. This is p, at the same time replace back what is cosine. Sorry, yeah, cosine. So this is cosine of theta is 0. This is cosine of theta is 1. And this is cosine of theta is minus 1. Now remember, if you think of this, where is cosine 0? See, if I take, this is a unit circle, it is 1 and 0. This is cosine, see? So when it is 0, this is 0 degrees or 0 radians. That's where cosine is 1. So cosine is 1, but if it is 90, this is where you have 0 comma 1, and here it is 0 minus 1, and this is minus 1 0. So you can use this mentally, think and say, okay, cosine of what angle is 0? It is pi by 2. So there, pi by 2. So, and then not only just that, there are 2. So I can write here theta is, one is pi by 2, and the other one is, you go across, and also here cosine is 0. Look at this cosine. This is cosine, right? The other one is sine. So cosine is pi by 2, and also theta is 3 pi by 2. Make sense? So these are the two, and all if you see from here, so these are two parts. So let me finish with this. So this will be pi by 2. So your first answer is theta is this pi by 2 plus, and because the period is 2 pi, so you put 2 pi k, and also pi by 2, this 3 pi by 2 plus 2k pi. So this is one of the set. Then if you go on the other side, where is cosine is 1, and you can see cosine is 1 only for 0 degrees and anything multiple of pi. So we can say here theta is 0, of course. Then you can go back 2 pi, so 0, 2 pi, and again 4 pi. So those kind of things, not just that, but also plus minus, plus minus. So we just write theta is 2k pi, where k is integer. So this is another answer. And if you go this side, now where is cosine is minus 1, and cosine is minus 1 is for this part. So this part, this pi, here cosine is minus 1, and that is pi. So we say, okay, theta is pi. And not just pi, and you can go on adding plus or minus 2 pi. So if it is pi, then you go around another 2 pi, so it becomes 3 pi, 5 pi, 7 pi, 9 pi, and it goes on. Or you can go, if this is pi, then you go pi. If this is pi, you can go minus 2 pi, minus 3 pi, so goes clockwise direction, and you can say, okay, we can direct theta is pi, that's the mean angle between 0 to 2 pi, but we can write theta is pi plus k 2k pi. Done. See? So your answers are this one, and also here. Hope this helps. This is problem number 5. I will continue. Sorry, this is problem number 6. We will continue in the class problem number 7, 8, 9. Okay. Thank you for watching, and hope this helps how to go about getting the answers.